Record to the cloud. Okay. All right. So yeah, we'll go ahead and get started. Yeah, let's just hop right into it. So, hey everyone, welcome to the Clean Code Workshop. I'm Shravan, one of the technical event leads at ACM Hack, and during this workshop, I'll be teaching you exactly like what clean code is, like what writing clean code entails, and like how we can analyze like different heuristics to start writing our own clean code in our projects and in our internships and in our PAs. So here on the screen is the check-in code. Make sure you check into the event to earn your points. Here are the links to the slides. Again, the check-in code. And if you don't already have an account, make sure you sign up on members.acmucsd.com. And let me make sure I check into my event before I forget. All right, cool. So again, for tools for the workshop, you're going to need Git and Java, and we're going to be doing some hands-on portion, some like refactoring of code later on in the workshop. So just before then, make sure you have these two tools. One note is that there'll be a bunch of code snippets throughout the workshop. They'll be written in different languages like Java, Python, JavaScript, and TypeScript. You don't need to know all these languages. But the reason why we have multiple languages is because I'm demonstrating different examples, using different examples to demonstrate clean code principles. And those examples happen to be in those languages. But also it's good to show that like clean code is language agnostic. You can have clean code in all kinds of languages, and we'll be kind of analyzing code from different languages to understand that. So yeah. I do want to quickly mention that a lot of the material in this workshop comes from this source material. This is a book called Clean Code by Robert Martin, and it is a phenomenal book for aspiring software engineers. It goes super far in depth to what it means to write clean code with like functions, classes, and all that. So this workshop is like a surface level introduction to clean code that this book dives into a lot more. So I highly encourage everyone to read this book who's like interested in software engineering. It's like a really, really good read. And it goes pretty far in depth into what it means to write clean code. So, all right, so for our agenda, I just want to quickly cover what we're going to be going over. We're going to ask ourselves, what is clean code? Why do we need clean code? Quickly going over how to write clean variable names, function names, and class names. Clean functions, clean comments, and then do a little bit of refactoring of a sample project, and other general tips and a conclusion. Question, how much are you getting paid to shill this book? I am getting paid $0.00, but Robert Martin, my Venmo is open, so slide in if you want. All right, so let's start with what is clean code. So the definition of what clean is subjective, right? So what Robert Martin did in his book is he asked some of the most renowned software engineers out there on what they think clean code is. So let's look at a couple quotes from some renowned software engineers to try to understand what it means. So Bjarne Stroustrup, I don't know how to pronounce that, but he's the inventor of C++, and he said, I like my code to be elegant and efficient. The logic should be straightforward to make it hard for bugs to hide. The dependency is minimal to ease maintenance, error handling complete according to an articulated strategy, and performance close to optimal. Clean code does one thing well. Okay, so there's a couple of things to dissect here. One thing that's like pretty obvious is that he said code should be efficient, which coming from the inventor of C++ makes sense because C++ is one of the most performant languages. But yeah, he really emphasized that code, like all code, should be logical, straightforward, minimal dependencies, make sure there's error handling. It should also be elegant. So there should be some kind of beauty to the code that you're reading. And we'll go over this in a little more detail later on. But that's one definition. Another is that clean code is simple and direct. Clean code reads well, like well-written prose. Clean code never obscures the designer's intent, but rather is full of crisp abstractions and straightforward lines of control. Am I too late for the check-in code? No, the check-in code is I'll type it in the chat again. Yeah, there you go. Thank you. That's the check-in code. Make sure you check into the event. But yeah, so I don't know who Grady Book is, but he brings up good points. He says clean code is simple and direct, right? And it also reads like well-written prose. So clean code is almost poetic in a sense, and it ties very similarly to the last quote about elegance. So clean code should not only be simple and like work, it should also be like pleasant to read. And we'll kind of go into detail like what that means later on. But yeah, one more definition. This person quotes, I can list all the qualities that I notice in clean code, but there's only one overarching quality that leads to all of them. Clean code always looks like it is written by someone who cares. So to write clean code requires some kind of craftsmanship that we're all going to learn a little bit about today. So just note that these are some of the most like well-known software engineers, and this is their stances on clean code. So what actually is clean code? It's very subjective, like I mentioned, but the general principles are that clean code should be easy, clear, and elegant to read, like we've seen. It should behave pretty much how you expect it to. So when you see a function, like you see any type of function, you see any snippet of code, it should do pretty much what you think it does, right? It should contain very little duplication, minimize the number of dependencies, and pass all the test cases. Passing all the test cases is step one, right? Your code should work, right? First, you make your code work, and then you make your code right? And we'll see how to do that in this workshop. Okay, so now we know kind of what clean code is, but why should we write clean code? Let's talk a little bit about writing time versus reading time. So I can guarantee 99% of the time, programmers spend more time reading code than writing code. And I'm sure you all can attest to this. For example, if any of you all have like done PAs or projects, like if you're working on your PA multiple times a week, when you come back to your PA, you don't immediately just start writing, right? You look at what you previously written, you look at what you have to do, and then after reading all that, you proceed and write new code, right? Similarly to when you join a new project or like you start a new internship, you're going to be reading a ton of other people's code to understand their kind of philosophies or their patterns that they use, and then kind of mimic that in your own code, right? So you read before you write. Similarly, when you read stuff on Stack Overflow or you read LeetCode solutions, you want to make sure, like, you got to read them, right? So it makes sense, since we're doing so much reading, that we want to make the reading process as easy as possible, right? Even if it means that the writing process takes a little bit more time, right? So let's take a look at this example function. This is a solution for the problem threesome. It's pulled straight from LeetCode, and I don't know about you guys, but I don't think it's very readable at all. Like, if you read this function, like, do you know what's going on? Like, it seems really confusing. Like, what is I supposed to represent, or what is L and R? Like, why do we have an L and an R? What does S mean? Why are we going to length nums -2? Like, why are we appending things, right? So it's kind of confusing. And we want to avoid writing this type of code, and we'll see through our heuristics why we should avoid this type of code. And by the way, this is the #1 ranked solution on LeetCode discussion. So like this stuff needs to change, and we're gonna see what exactly needs to change here. But yeah, I do want to note one thing on university versus industry. It is generally harder to justify writing clean code in college because, especially in PAs, because once you pass your PA, like once you pass all the test cases, there's no incentive to clean up the code, right? Because you're not going to look at it later. No one else is going to look at it later. No one else is going to use it later, right? So there's no incentive. But in the industry, this is wildly different, right? There are going to be tons of other people reading your code on a daily basis, right? On your team, everyone's going to read your code. You are going to read your own code when you're working on a different project, right? And if it's harder to read the code that you wrote, then the entire project is slowed down, right? Because people are trying to understand catch bugs, understand the logic, right? So it just takes up so much more time. So writing clean code means less time fixing bugs, means less time in code review, which means faster developer throughput, better performance, more promotions, more money, and self-fulfillment. So just write clean code. That's the TLDR. Yeah. Okay. So enough about the philosophies of clean code. Let's dive into some heuristics on how we can write cleaner code. So let's start with variable names and just naming in general. So in programs, variable names should be intention revealing, they should be type revealing, have meaningful distinctions, and be easily searchable. All right, what does this all mean? All right, intention revealing variable names. So variable names should clearly reveal what it's storing and what it's used for. So I'll open this to the chat. What do you all think is happening here? This is like a pretty simple algorithm, it looks like. There's some like multiplication and modulus going on. Does anyone know what algorithm this is? Like what's happening in this code? Sum of digits, not quite. Same number, not quite. See, it takes some time. It takes some time to understand. Yes, it's reversing the number. So this function reverses an integer. But how long did it take for you to figure out that this is reversing an integer? It took like quite a bit of time, right? And if you have to do this for every function, like that's going to take up a lot of time. How about something like this, right? The function name's the same, but we just changed the variable names, right? We have reversed int, we have rightmost digit. Like when you read the first line, there's like a 90% chance like you know what's happening, right? There's like some integer that's being reversed, right? So this is why we want to have intention revealing variable names, right? We want to see like what does each variable do, right? Like for this example, like how do I know what z does, or how do I know what y does? Right here, oh, I know z is the rightmost digit and y is the reversed integer, right? So one thing you'll also notice is that the code looks a little more verbose, right? Our variable names are kind of long, it looks like, but this is a very good trade-off to have. Even though you're going to be writing a little more code, and you're eventually going to have to read a little bit more code too, just because the code is longer, it's so much more worth it because it's a lot easier to understand. It's more easier to understand explicitly what's going on than trying to guess what's going on, like what does y do or what does z do, even though the code itself is shorter. So let's look at this. This is a refactored version of the same three-sum code that we saw. So I wrote this. I basically just changed the variable names. Like that's pretty much all I did. So it does look a lot longer. Yes, it looks slightly more complicated because there's just a lot more text, right? But hopefully when you read this code, it makes more sense, right? Like what you're reading. So we have a first index, a left index, and a right index, and we have a triplet sum, right? And like the details of the algorithm are kind of tricky, but like the variable names really help like what's going on at each step, right? So we change our left index or we change our right index depending on if the triplet is less than 0 or greater than 0. So really have intention in your variable names when you're writing variables inside like in your code. And if anyone has any questions along the way, feel free to ask. But yeah, let's move on to type revealing variable names. So another heuristic, variable names should reveal the type of the data stored without having to look at the type. And this is even more important in weakly typed languages where there's no actual type defined. So the reason why we do this is so that when you look at a variable, you won't have to guess its type, or you won't have to be confused by its type. The worst thing is that when you write variables that are confusing. So take a look at these examples, right? Here we have a string called num, which is a string, but it stores a number, a stringified number, right? So it's slightly confusing because if you just see the variable num in your code, you would expect it to be a num, but it's not, it would be a string. Same thing with date, right? In many programming languages, there are date objects. So if you see date, you would assume that date is a date object, but it's misleading because it's actually a string object here. How about the next two lines? We have Boolean expired equals false and date expired equals new date. So the reason why expired is an ambiguous name because expired can mean multiple things, right? Expired could be the time that something expired, or expired could be the fact that something expired or not, right? So in both cases, like it could be a Boolean, but it also could be a date. So we want to make sure that there's some distinction. Like if I see the variable called expired, I know that it's a Boolean, or I know that it's a date. So how do we make those distinctions? And also this applies to like things like indices, so that like if you look at int left equals 0, right? You don't know what left is, right? Is left an element or is left an index of an array? So that's also ambiguous. So good naming practices are making sure that it's clear what is being stored in a string, like for strings, right? So if you have a string called num, I would rename it to num string or num str, right? So that it's clear that it's storing a stringified version of a number. Same thing with date, right? I would rename date to something like date string or date str, right? So that if you see the variable out there in your code, you know exactly that it is a string, right? For Booleans, I like to follow this convention where the Boolean asks a question so that it's not confused with any other type of data. So for example, expired would become is expired or has expired. And then expired, the date would become something like expiration date or expired at, so that those distinctions are there. Okay, let's move on to meaningful distinctions. Another heuristic, variable names should have meaningful distinctions between one another. So let's look at this code, right? So this is a arbitrary algorithm for finding a shortest path. I don't know if it works or not, I just wrote it, but we're gonna look at, like if you can see the parameters, right? We have node 1, node 2, and node 3. And then you see, okay, if node 1 equals node 3 or node 2 equals node 3, then we return integer. Okay, so if node 1 or node 2 is equal to node 3, but I don't know why I'm making that comparison, right? Or if node 1 equals node 2, then I return node 1 dot length. Like I can't tell what's going on because the variables don't have distinctions between one another, right? I know what the variables are, like I know their type, they're nodes, right? Because they're labeled as nodes, but I don't know that there's a distinction between one another. But here, if we just describe the variable names better, right? We have start node, end node, and obstacle node, then okay, it makes much more sense, right? If we hit an obstacle, then we just return like a max value. I mean, if we reach the end, then we return the length, and then we just traverse all the other neighbors. So this is why meaningful distinctions are also very important. Okay, lastly, on variable names, we want to make sure that variable names are easily searchable, so that if you need to debug a variable, if find a variable, for example, it's easily searchable with grep or with an IDE. So let's look again at this solution here. Are these variable names easily searchable? I don't think so. Like if you search for L, like that's going to pull up a ton of results, right? Same thing with S, same thing with I, same thing with R, right? So this is why having searchable names is very important, so that like it's easier to find variables, and it also follows the other principles, right? So if you're forced to write a longer name, you might as well make it intention revealing and type revealing and all that. So one heuristic to follow here, this is generally what I follow, and this is what Robert Martin explains in his book as well, is that the length of a variable is dependent on its scope. Okay, what does that mean? What this means is that variables with very small scope can have smaller names, while variables with larger scopes should have longer and more descriptive names, right? So I'm not saying to like never use I in a for loop, right? You can totally use I in a for loop if it's just like the lowest level of a function, right? If it's like, if there's like nothing else nested inside that for loop, or that for loop isn't gigantic, then totally use I, right? Because I is a general convention that everyone knows, like I is an index, right? So I is totally good for small for loops, but for larger for loops, for like the threesome example, since the code is like quite large, like the meaning of I starts to become more and more muddled. Like you have to remember, oh, what does I mean? Like what is the intention of I? So whereas like a more descriptive variable name at a higher scope, you won't forget what that variable is supposed to do, right? So that's why I just generally follow this heuristic with variable length, name length. Okay, let's move on to function names. So for function names should describe some sort of action that is being performed, right? So this makes it easier and clearer to know exactly what is happening within the function, right? So let's look at the 3sum code, right? This is the function name that LeetCode provides. So I don't know what the hell 3sum like means. Like, is it supposed to be return all the sums, or like what exactly is it supposed to do, right? However, if I rename it to find all triplet sums or something of that sort, then I know that the function is supposed to return all the triplet sums, right? It's not ambiguous. Because if you look at just the function name 3sum, it could be a void function, it could be return an array, it could return like a tuple, it could return all types of things. But naming the function like this makes it really obvious what is being returned, right? Another thing, def task complete. Like, again, you don't really know what it does. Is it returning a task? Like, what kind of action is it doing, right? If you rename it to something like mark task as complete, okay, it's pretty obvious, like some task is being marked as complete. That's what's happening. That's exactly what's happening inside the function. Lastly, that's like def loading, like is it loading something? Is it checking that something has loaded? It's also ambiguous, right? But if you do is loading, then I know that this is a Boolean function that returns true if something is loading, right? So a note here, Boolean functions, similar to variables, should ask some kind of question. Okay, I want to quickly touch on class names. Class naming isn't as hard as function or variable naming. Generally, just have it be a noun or a noun phrase, and not verbs. Like, I don't know what this, like the first line of remind user, reminder equals new remind user, like you don't even know what that means, right? Like, what is the object supposed to store? But if you do something like user reminder, then it becomes a lot easier. Like, oh, this is some kind of reminder object, right? So very quick note on class names. Okay, let me sip some water. So now let's move on to clean functions. Okay, so clean functions should do the following. They should be small. They should do one thing. They should minimize the number of arguments and should not cause any side effects within the program. And like we mentioned earlier, clean code and especially clean functions should pretty much do what you expect them to, right? When you look at a function, you should know what that function does without even reading through the function. Okay, let's start with small functions. This is a quote that I love from Robert Martin that he quotes in the book. He quotes, "The first rule of functions is that they should be small. The second rule of functions is that they should be smaller than that," right? So functions should be ridiculously small. How small, it just depends on the use case, right? But they should be as small as possible. Why? Because small functions help the reader understand exactly what's going on in each subroutine, right? There's no confusion because the function itself is small, right? It's like easy to read through and understand. It also helps you find and fix bugs easily, right? If you have like a 100-line function and there's a bug within that function, you have to go through all 100 lines to figure out where that bug is. Whereas if you have a bunch of 4 to 5 line functions, it becomes really easy to find like where exactly a bug is. And it also, small functions abstract away lower level details inside other functions. Okay, so what is, we'll go into abstraction a bit later because abstraction is kind of an intermediate topic, but hopefully this abstraction levels will make more sense later on. But let's take a look at an example here of a not so small function. So this is straight from ACM's membership portal. If we can just click the link here. Let me just hide this. Okay, so we have a function here. This is part of our ACM membership portal API, and it is our merch store service. So everyone is saying, where is ACM store? Where is ACM store? ACM store is here. It's just in the back end. It's not the front end. So you could just use the back end, but we don't have any items or anything. So yeah. So this is just one of the functions inside our merch store service. And let's go ahead and just read through this function, right? So it's called place order. So we have an order and we have a user, right? So it places some kind of order, right? Descriptive function name, you know exactly what's happening. But if we scroll through here, there is a whole lot of stuff going on here, right? We have like repositories, we have mappings, we have like limits being checked, we have like iterations, like dear God, like what's happening here, right? We have like more for loops and if statements, like a whole bunch of nested stuff. We're filling arrays. we're promise.alling, like what is going on here, right? There's a whole lot of stuff going on here. And this function also, just for reference, is like exactly 100 lines, right? So not a terribly large function. You'll definitely see larger functions in your lifespan, but yeah, this function is quite confusing. There's a whole lot of stuff going on. So how can we kind of change this function or make it more easy to understand? So let's hop back into the presentation. And yes, I am roasting my own backend code. I didn't actually write it, but yes, this code is quite chunky. Okay, how about something like this, right? We've condensed a 100-line function into 6 lines, right? So let's abstract away everything except the core details of the place order function, right? We get and verify item options, right? So make sure that the items exist. Make sure that we can purchase the item, right? Make sure that they're in stock, make sure the user has enough credits, create the order, and then send a confirmation, right? Much easier to understand than 100 lines. And of course, these are all going to be functions that we have to write. But hopefully it makes a lot more sense, like why we want small functions, right? Because this is just way easier to understand and debug. Okay, so let's dive into a little bit of abstraction and like what we can do. So another heuristic of functions is that functions should do one thing. Okay, what exactly is a thing, right? So the key to this is abstraction. So functions should perform steps that are exactly one level abstraction below its stated name, right? This is what Robert Martin proposes, and it makes a lot of sense. And this is a kind of a way to figure out that your function is doing one thing. So the whole reason we write functions in the first place is to break down routines into smaller steps, right? That's why we write functions. Otherwise, we would have like our main function would just be like a billion lines long, right? We wouldn't need functions. The whole reason we have functions is to break a routine down into smaller steps that are at the next level of abstraction, right? Okay, so what is abstraction? I keep saying this word abstraction. So abstraction is the idea of reducing code complexity by hiding unnecessary information in lower level components or functions, right? So like I said before, it's the key to making functions short and clean, because anything that isn't at the same layer of abstraction or is too low level for a function just goes into another function, right? And having different functions at different layers of abstraction make it a lot easier to understand bugs that happen, because, oh, if I know a bug happens at this layer or at this functionality, I know to immediately skip to that layer instead of having to go through one gigantic function, right? For in the merge store example, let's say my email doesn't send, right? I know exactly where to look, right? I check the email confirmation function. So one tip here that Robert Martin says in his book is that if you can describe a function, what a function does in one simple 2-paragraph, then it is short enough. Okay, let's dive into an example. So this is our example with the same function that we write. And let's define what this function does in a 2-paragraph, right? So to place an order, we check that if the items exist and are in stock. And if the user has enough credits and hasn't exceeded their purchase limits, then we place the order and send a confirmation. It is multiple sentences, but it's not a quite concise paragraph, right? Let's take a look at our old function. Let's try to write this in a 2-paragraph. So to place an order, first we refresh the user in case of concurrency issues and then instantiate a merged option repository. Then we get all the existing options and check if the user submitted any bogus options by iterating over the option array and filtering for hidden items and mapping to a UUID where we throw an error if there's a difference between missing and requested items. Yeah, so there's clearly more than one thing going on here. That was just like 8 lines of a 100-line function. So there's clearly a lot going on here that needs to be abstracted. So it still might be confusing what abstraction is and how to identify layers, but when we refactor our code, hopefully it'll make more sense. Okay, so for function arguments, quick heuristic, you should minimize the number of arguments a function accepts, right? The more args, the higher chance a function is doing more than one thing with those, right? So a large number of arguments makes testing even harder as well, right? Because you have to test for every combination of parameters to test the entire function. Whereas if a function just has like 0 parameters or 1 parameter, you just have to test that parameter, right? And higher quantities of the same arguments. I think I switched arguments with parameters, by the way. So I think this is supposed to be parameters. That's my bad. But yeah, so high number of parameters mean that the functions are tightly coupled and should probably work better in a class. And we'll take a look at this in our refactor as well. But basically, it minimizes function arguments, the number of arguments. Yeah. So here's an example. What do you think when you see something like this, right? There's seven parameters there. Like you have no idea what's going on, right? So why are we passing in HTML and CSS, and like why are there random nulls and falses and trues? It's like really confusing. So if you pass in many fields that are all related, like it seems like HTML and CSS are related, it's probably just better to create a class and have those fields as instance variables. Quick note on side effects. So what function side effects are is a function that does something that is not explicitly mentioned in its name, right? That is a side effect. So according to Robert Martin, side effects are lies. By including a side effect, you're basically lying to your fellow developers. And we all know that lying is bad, right? Okay, in some cases it's okay, but like in this case, lying is bad. You don't want to lie to your developers, right? So make sure you're explicit and don't have side effects. So let's look at an example of side effects. So here we have a function in JavaScript called add item to cart, right? That takes in an ID, a name, a cost, and a quantity, right? So we create an item, we get our current cart. So don't worry about if you don't know what local storage is or JSON parts, don't worry about it. Basically, we're just creating an item, adding it to our cart, setting it in our storage, and then we're doing something with the add item button and we're disabling it. Okay, what is that? So that is called a side effect, right? When you think about adding an item to a cart, like it should add the item to a storage, right? That's what you would think a function called add item to cart does. But why is it disabling a button? Is that intended behavior? Like you don't really know, and it just becomes really confusing. And it makes the button disabling temporally bounded to the addition of an item. So what that means is that every time an item is added, then the button is disabled, which may or may not be the behavior that you want. So just make sure that the function doesn't have any side effects and it's only doing what its function name says, right? Otherwise, your function's probably doing more than one thing anyway. Okay, last section before we hop into refactoring, I just want to quickly cover clean comments because commenting is very important. Okay, clean comments. So your code should be self-explanatory, right? This means that oftentimes having clean comments just means having no comments, right? The reason we do clean code and have variable names and function names is to minimize the number of comments because our code is so easy to understand that it doesn't need comments to read through it, right? So we'll see a couple of examples of redundant comments, but sometimes we actually do need comments because there's some behavior that we can't capture with just the variable name, right? So we actually would need comments, and we'll see why, like where and where not, like we need comments in a few examples. So let's look at this first example. We have three variables. We have a const items is some array. We have const loaded is false, and const user is some object. And we have a comment that says checks if data has been loaded. Okay, so this comment is telling the reader exactly what the variable is storing. So why not just rename the variable, right? We can omit the need of comments by just renaming the variable, right? So add in the chat, feel free to add in the chat, like, what do you think loaded should be renamed to remove the comment? Okay, is loaded, is data loaded? Nice, yeah. So remember, we want Booleans to ask a question. Is life real? That's a good question, Matei. That's a very good question. So yeah, I would say is data loaded, or is loaded, or has loaded. are very good examples. I'd say is data loaded is probably the best because it's very explicit in saying what it's loading, right? Because if you just have is loaded, like what's loading, right? So you know it's a Boolean, but you don't know what's loading, right? So we want to be as explicit as possible. So I would say like has data loaded or is data loaded is probably a good variable name. And yeah, this is like basically what the last comment is doing. So don't have comments like this. This is a big no-no. So yeah. All right, let's look at number 2. So this is a DFS algorithm, just like this, the first couple lines of a DFS algorithm. Basically, we have the first snippet says stop search if current element is out of bounds, right? And it has if m is less than 0 or m is greater than like the grid. So it's basically checking if the current indices are out of bounds of the grid, right? So again, this is kind of redundant because we don't actually need this comment if we just capture it in a variable name, right? So if you look at the second line or the second function, we have is cell out of bounds, right? That's a nice name to have that basically summarizes what the comment says, right? And that makes the if statement even more clear, right? Because it reads just like English, right? If is cell out of bounds, then return, right? It's like almost, it's not really English, but like it's so much easier to understand if you just capture it into a different clean descriptive variable. So let's look at another example. So this is from the same function, the place order function for the ACM merge store. And we have this comment over here, checks that the user hasn't exceeded monthly lifetime purchase limits, right? So we have this comment that describes exactly what the next 6 lines of code do. So what if we just put that in a separate function and just call it like with that comment, right? So like we do earlier on in the slides, we have like a verify function. This comment isn't needed because it signifies that this function is doing multiple things. And it basically summarizes the behavior of this exact subroutine. So we might as well just abstract it to a different function. So comments like this kind of should make you think like, should this code be here or should it be in a separate function? And just define what that behavior is, right? So that's that. Okay, last example. Here's a different example, also from ACM's membership portal API. It's the Get Leaderboard Service. So the leaderboard that you all see on the portal or in Matei's new breadbot command are that uses this function, right? So I wrote just a few lines at the beginning of the function. We can read the whole function in here, and I'll check that function out later. But we have the first few lines of this get leaderboard function, right? We have a from and a to, so it gets the leaderboard between 2 points in time, right? So okay, we're multiplying something by 1,000 and multiplying another thing by 1,000. I don't know what's that. So then we're getting the earliest timestamp. Okay, why are we getting the earliest timestamp? And then if our from is given, then we set it to the start of the day if it's later than the earliest, otherwise it's null. Like what's going on here? Like it's kind of confusing what's going on here, but if you think about it, you can't actually rename any of these variables to make it any clearer, right? So this is a good a point to use comments. So if we just check out a commented version of this, and this is how the code actually is in our portal. We have comments here. So okay, you could see, oh, we multiply by 1,000 because we need to convert seconds to milliseconds. Okay, that makes sense. And then here's another comment. Like if each bound is in the possible range, then we round to the nearest day. And the possible range is the earliest recorded points to the current day, right? And if our left bound is after the earliest recorded points, then we round to the start because that's our behavior. And then if the right bound is before the end of the day, then we round to the end of the day, right? So good comments are very important because it really helps you understand what's going on, because this is just unreadable. Like you have no idea what's going on, but here it just makes a lot more sense. And I can go ahead and just show this function. We have a little more stuff going on, but like Yes, this is our leaderboard function. So you see very good comments to describe like what's going on at each point, right? So this would be a good demonstration of using comments. Let's go back here. Okay, so I lectured for 42 minutes. It's about time to start actually doing some coding. So, all right, what are we gonna do in this workshop? So what we're gonna do is analyze a very simple program that is just a number guesser. So all this program is a guessing program that prompts the user to guess numbers between a specified range, right, from like 1 to 10. And then the user just has to guess the number, right? And the amount of guesses is shown for each round, and the minimum number of guesses is stored across rounds. So you could play the game multiple times. All right, so we are going to have a look at this function and see how we can refactor it. So everyone should go to this link. Let me just hide this. So this is our GitHub repo. Let me just add this to the chat. Lab is mandatory. It is due Thursday night, 11:59, or else you're all fired. So please attend. Please do your lab. All right. So yes, this is our GitHub repo. Everyone make sure to clone the repo. If you, I'll just walk through that right now. So make sure to click this code icon, copy this, and then head over to your favorite terminal. Sorry, was someone saying? All right, never mind. Yeah, hop over to your favorite terminal, hop into your favorite directory, and just do git clone and then paste.
To git clone.
Yeah. Okay, so now that you've cloned this repo, you should do cd number guesser, and then you'll be at our repository. So we do ls, we'll have main and readme, right? So let's check out what this code is. So you can open it in your favorite editor. I use VS Code because I love Microsoft. I'm just kidding, but VS Code's great. So, okay. Whoa, fancy terminal. Okay, yes. This is this terminal is called Hyper. It's a Electron-based terminal. It looks pretty slick, but yeah, you can customize terminals like Bash and Zish like to your customization. So I just use Hyper. That's what it's called. Yeah. But yeah, this is called Hyper. So, all right. So we have this function here. Let me just walk through this. So we have this program. It's called just main. It's a class main, and we have a bunch of code for a number guesser. So let me just run this program. So we can do Java C main.java and then Java main. So this will compile the Java code and then run it, run the class that's generated. So we'll do that. And then we get this, provide an upper bound number for guessing. All right, let's do 20. So we're gonna guess a number between 1 and 20. Do we have any takers for what we should guess? 1. All right, thank you, Daniel. Guess 1. All right, so incorrect. It's greater than this value. All right, let's do 16. So we know it's supposed to be greater. It's still greater. All right, let's try 18. It's still greater. 19. Okay, 19. So we see that four guesses, and our fewest number of guesses so far is 4. All right, so let's play again. We can do some binary search. 10 is less 5. It's less 3. It's less 2. Okay, 2. It also took 4. So I'm just gonna do one more. 16, 5, 10, 4. No, I just trolled. 7, 8. Okay, so you see I took 6 guesses, but our fewest number is 4, right? So this is the behavior. Simple application, but let's take a look behind the scenes, what's going on. So let me go back to the slideshow. Okay, so we've compiled it, and let's see what to do next. All right, so first we make it work, right? We make our program work, it works. There's probably some bugs that y'all can find, but for the most part, it works. but it is quite sloppy and has to be cleansed of its filth, right? So let's think about what are things that we notice that are dirty about it. So let's go back to our code and make sure to think about variable naming, distinction, abstraction, complexity, all that kind of stuff. So any takers, what do you see that is filthy about this code? Let's just scroll through here. Well, let me just walk through this real quick. So first we see we initiate a scanner, we print something, right? So scanner is just for standard input. It's in Java. Okay, Daniel, thank you. I don't know why y'all flaming Java. Java's a pretty dope language. It's like very crisp language. So okay, we're printing stuff. We're getting our inputs from standard in. Okay, then we initialize num and count, and then min, and then running. And then while we're running, we have this giant while loop. And okay, we're doing res, and this is some operation going on here. So the point is there's a lot of stuff that's kind of unclean about this code, right? So the basic idea is we get a random number, and then while the number is not equal, while our guess is not equal to that target, we prompt the user to guess. And if it's less than, then we say incorrect, it should be greater than, or if it's greater than, we say sure, it should be less than, right? And then we do in.next line for some reason. And then we get a min and then print our guesses and then ask the user to play again. Okay, so does anyone have like any takers for what's disgusting? Like a specific example of what's not correct about the style of this code? File extension. All right. Next time I'll write my code in a TypeScript to satisfy everyone. But yes. Anyone else? Variable names. So what specifically about the variable names is irking you? Right. What does num do? Like, okay, num stores a number, right? It's like we know that the type is a number, so it is type revealing, but I have no idea what num does, right? Okay, what's count? I have no idea what count is, right? Well, like, is it what am I counting, right? Like when I run the program, I know that, oh, I'm counting my my guesses, but I don't actually know what I'm counting if I just look through the code, right? Min, okay, I have this giant number. I don't even know what number that is. Is that 10 million? Yeah, 10 million. Also, side note, a lot of languages do this. You can have underscores inside variables to like distinguish or inside numbers to distinguish, like serve as commas. So, but again, magic number. I don't know what 10 million is doing. Why is the minimum 10 million? Running. Okay, what's running? I don't actually know what's running. Is the game running? Am I running? Like, why am I running? Like all this kind of, like, I have to ask all these questions. Your refrigerator, yes, your refrigerator is running. Like, it's just so ambiguous. This, Matei pointed out, this is also very unclean. I don't know what's going on here, right? Like, I'm casting this math.random to upper -1 + 1. Oh, sorry. Like, I don't know what's going on here. Should we run? Dude, by all means, after this workshop, go for a run. So by all means. So yes, a lot of unclean things about this. Like other people said, it's not in main, it's not split into separate functions. It is just very dirty. So okay, what can we do to fix this? So let's break this function down into what's actually happening. And I kind of, like when I described the function, I kind of explained what's going on, right? So what we're doing here is we're initializing a ton of variables, right? So here I'll just comment this out, right? So we're like initializing variables, right? And then we're getting the user guess, right? Or sorry, the upper bound of guessing, right? That's something we're doing here. All right, we're initializing a ton of variables here, more initialization. Okay, then we're like actually running the game, right? And we're getting a random number here, getting a number. So this is between 1 and upper, right? So 1 and, I don't even know what the number is called, upper, yeah. 1 and upper, right? 1 and upper, inclusive, right? And then here I'm asking the user to guess, right? So this is actually down here. Oops. Let me just copy this. So this is happening down here, right? I'm asking the user to guess. I'm getting the input. Again, there's some kind of duplication going on here. I don't know if you all noticed, like there's duplication of asking the user and getting the input, right? In.next and system.out. So maybe we can bring that into one function, right? Okay, we're doing the actual guessing, right? We're incrementing count, and then I don't know what this is, right? Why are we just doing an in.next line? So the reason behind this is because in.next doesn't handle new line characters. So we need to flush the input buffer after the guesses, right? So I just add a comment there. And then we're actually displaying the results, right? And then what we're doing here is just, here we're just asking the user to play again, right? So, okay, now we have these comments that make it a lot easier to understand what's going on. But like I said before, we should just abstract these into separate functions, right? So let's go ahead and do that. What we can do is we know that there's a lot of coupling happening here, right? We know that num is used multiple times, right? Count is used multiple times, min is used multiple times, we're reading input multiple times. So let's create a class, like a guessing game class, that will have all these as instance fields and that we can just call get at our will, right? Instead of just creating a bunch of functions here. So if y'all are following along, let's just create, let me just hide this real quick. Let's create a new file called number guesser. That is a class, right? And what we're going to do is we're going to start breaking all this code into this class, right? To make it really crisp and really clean. So let's read through again what we're doing, right? We're initializing variables. Okay, so what variables do we need, right? What do we need? So we need the upper bound. We need the number. Okay, I don't even know what num is. So it's our current guess, right? So this is our current guess, our maximum number that we can guess, right? So let's write this down. So private int current guess, right? Private int max number guessable, right? So remember, like very descriptive variable names, right? So we have our max number guessable. We also have our target number, right? Our res here. So we have our target num, right? What else are we storing? We have our min, right? So we have our min num guessable. What else do we have? We have our count, right? So we have our private int current. So what should we name this? It's basically the number of guesses we have right now, right? So like current guesses count, right? And then private int, we also have our minimum, right? So just min over here, we have our minimum guesses count, right? So min guesses count. And lastly, we have our scanner. Let me just import this, right? And we could just call this like standard in, std in or in. Yeah, let's just call it std in. Okay, already much better, right? Descriptive variable names. We know exactly what is going on in each variable, right? Okay, let's define our constructor. Public number guesser. Okay. I don't think we'll need any variables, right? Because what I'm imagining is in our main method, we just create a number guesser object and then we play the game, right? So it would look something like this, right? So we have like number guesser equals new number guesser. and then guesser.playgame. Right? This would basically be the entire main method. And obviously we don't have a play game method, but we're gonna write that soon. Okay. So let's just initialize our variables. So we're gonna create our standard in, right? So new scanner system.in. Okay. And then we're also gonna have our current guess. So we're just gonna initialize all our variables that require user input just to be like 0 or 1. So current guess equals 0. We're going to do our target number as 0. Actually, over here, what did we have it as? Yeah, so we'll just define our target num as 0. We're also going to have our current guess count. Equals 0. Our min guess count. This is going to be integer.maxValue because remember, if we're doing mins, we want to make sure it's stored as the max before so that it always updates to the minimum value. And then what else do we need? We have current guesses, and then we want our min num guessable. So in our function, we define it as 1. So it's very subtle, but this random number generator, this +1 is basically the min, right? So for our program, we're just going to have our min be 1, right? And then our max, we'll just also set to 1, but that'll be changed when the user inputs their guess, right? So, okay, we have our constructor. Now let's create the actual logic of our application. So, all right, so we have our play game method here, right? So play game. So we're going to have public void play game. Okay. So what's happening when we play the game? All right. So we already initialized these, right? So I could just remove these. Okay. We get the upper bound of guessing. Okay. Let's create that function, right? So let's create a function called, make sure it's private, right? Because we don't need anyone else to know about this function. Let's call it query user for upper bound, right? So this is a long function name, but remember, we prefer long function names over shorter ones because now we know exactly what's happening in this function, right? So what do we need to do, right? So, okay, first let's define here, right? So what's going to happen is we're going to query the user for upper bound, right? And then we're going to have remember over here, we're playing the game, right? So I'm going to quickly like route the skeleton of this. So anyone have any suggestions for what we can rename running to? Because running is very ambiguous here of like what's actually running. So something here to represent what's running. Is playing. That's definitely better, but still it's like what's playing, right? So I'd say like an even better one would probably be like is game running, something like that, right? So like it's very clear like the game is running, right? Because we're playing the game, right? If the game is running, so it's definitely going to be running here. So boolean game is true, and then while is game running, what are we going to do, right? Let's do this later. Let's just handle this query user for upper input, right? So what do we do, right? We provide an upper bound for guessing, and then we get the input, right? So the thing is, remember I mentioned earlier, we have this duplicated a couple times, right? So this is a classic example of duplication, even though it's just 2 lines. Here we're querying for integer input, here we're querying for integer input, and here we're querying for string input. So let me create a function that will just return the queried value, like given a prompt, right? So let me define a function called query query integer input given a prompt, right? So I'm going to sysout it, right? And I'm not going to do println, but yes. And then what we're going to do is we're going to have a return this.stdin.next int. So we have cut down, I don't know why I put this as void. This is supposed to be int. My bad. But yes, here we have we're printing and then we're getting the response, right? So just 2-line function, but now we can do it in 1 line, right? So the lower number of lines, the better for these functions, right? So what we're gonna do is, okay, we're gonna query integer input, right? And this is gonna be the provide upper bound for guessing. And we're going to set this as our max number guessable equals this. Okay. So one thing I do want to mention as an aside is I'm using this dot like everywhere. And it is redundant in a sense, but the reason why I use it is because it makes it really obvious like where that variable was defined, right? If I just have this, for example, like just this, then like initially I think, okay, did I ever instantiate this variable? Like, where's this variable from? I don't instantiate it anywhere here, but if I add this dot, then it makes it really clear that this variable is defined in this instance, like somewhere above. So just a side note, like if you're in like CSE 12 or CSE 100, like classes, courses that use classes a lot, then like I would definitely encourage using this for the PAs, but yeah. Okay, so all right, we create a user for upper bound, and then we have these functions, right? Okay, so now let's get to the game logic. Okay, so what we're gonna do is, okay, let's see here. Remove that, right? Okay, we get a random number between 1 and upper inclusive, right? So basically what's happening here is in this giant function is we're running a guess session. If you think about it, like it's a session where the user guesses back and forth with the program, right? So let me define a function that will let me just do like, while is game running, this dot run guess session, right? Because remember, we want to make functions as small as possible, right? So if I run the guess session, then I have my business logic in here, right? And then later on, I'll have to do other things like display my guesses count, and then I would have to ask the user if they want to play again, right? So I can handle those later. But let's do run guess session. Okay, so now we have this function. And okay, what are we doing in the run guess session? Let's go back to our function here. We are getting a random integer. All right, so let's definitely clean up this code right here. So what we're gonna do, right, is we have the this.target num, right? So target num is our new res, and we're gonna set that to a random number, right? But again, we talked about here, like, I don't know, this is very unclear what's happening, right? So what I'm gonna do is I'm gonna write a function called something like get random number in guessing range, right? Very, very long function name, but also it defines exactly what we're doing, right? So it's totally fine to have this function name. So let's refine this now. Okay, now we need to return an int. So now we just copy this, right? Go over here, copy this, return this. All right, we just have to rename our variables now. And let's say, okay, so we have our upper. So this is this dot max number guessable. So 1 it's kind of a magic number here, if you think about it. Like, I don't know why I'm doing 1, right? Like, why am I subtracting 1 and then adding 1? Well, it turns out that this 1 is the min number guessable. So we just have to switch this with this dot min number guessable. Okay, a lot crisper, a lot cleaner, right? Reading this makes a lot more sense, right? We set our target number to be a random number in guessing range, right? Okay, now what do we do? So now it's the logic of our application, right? While the number is not equal to the result, we guess, right? So while this dot current guess is not equal to this dot target num, here we have to do another function, right? This is another thing that's happening. We're asking the user to guess, right? So this dot ask user to guess, and we're going to define this function soon. Okay, so you see how every function so far is a maximum of 5 lines, except the constructor. Hopefully you're starting to see the use of this. Like, it becomes so much easier to understand, like, oh, when I play the game, I query the user for upper bound, and then I run a guess session while the game's running, right? And we're not done yet, but at the end, hopefully it'll start to make more sense, like why we want smaller functions. But yes, let's go to ask user to guess. So let's go back to our main function. Yes, we have our another input, right? So we can just use our existing function. And then we have this logic, right? So let's go ahead and do that, right? So this dot, so let's start with what are we doing? We're guessing a number between 1 and upper, right? So we're going to have our current guess equal to this dot query integer input, and then we want to copy our prompt. Right, copy the prompt, guess a number between 1 and this dot max number guessable. Okay, reads pretty quickly, right? Our current guess is the integer input of this prompt, right? So we prompt the user, and then what we're going to do next is increment our guess count, right? Because when the user guesses, they increment the count, and then we have our logic here, right? So just copy this, paste this dot current guess is less than this dot target. Current guess less than this dot target. Okay, so here, same logic, very short. It makes a lot of sense, right? If the current guess is less than the target num, right, that means they guess too low, so we have to go greater. If they guess too high, then we have to go less, right? Makes sense to me. This is also a very, very short function. Okay, so we ask the user to guess, and then what? So this is all done. This is done. Okay, we need to flush the input buffer after the guesses. Okay, in dot next line. So, oops. Again, with the comments, we can abstract this into a crisp function that just lets us, that we can just call, that'll make sense when we read it, right? So what we could have is this dot standard in dot next line, right? But again, it's the same problem. Like, we don't know why this is being called, right? So instead of having just this line or having a comment, we can just write a function that just does this. So this would be just a one-line function, and I think it's totally fine and also encouraged, so just to make it really clear, like, why that one line is being called, right? So let's have a function called flush remaining input buffer, right? And all it does is this dot standard in dot next line. And then here we can just do this dot flush remaining input buffer. Okay, so let's go through this, run our guess session, right? We get a random number. we ask the user to guess, and then we flush, right? So this looks like it's done, right? We get the number, we ask to guess, we flush. So let's go back up, right? So we run the guess session. So this is all done. Now we need to display the results, right? So let's do that now. How do we want to do that down here, right? So we can do something like this dot display completion stats. Again, very verbose function name, but it does exactly, it shows the user what exactly is happening in the function. So let's define that down here. Private void display completion stats, right? And all we're gonna do is go here and copy this, right? So copy all this, boom. This is gonna be this dot min guesses count is the min of this dot min guesses count, and this dot current guesses count, right? And then we print these because the number was this dot target. Number of guesses is this dot current guess count. Fewest number is this dot min guesses count. Also another freakishly short function, but it's very clear what exactly is happening inside this function, right? Displaying the completion stats is just printing to the console, right? Okay, what is the last thing we need? There's one more thing here, so we did this. It's asking the user to play again, right? So this is a Boolean function, right? If we're gonna write this in a function, it's gonna be, okay, does the user wanna play again, right? So up here, what we're gonna do is we're gonna, and this is basically gonna decide if we run the game or not one more time, right? So we're gonna have is game running equal to this dot does user want to play again, right? So another really long function, but it makes it clear what exactly is happening, right? So let's define this down here. Private Boolean does user want to play again. And remember the Boolean conventions, we ask a question in a function that returns a Boolean. Okay, so we're just gonna take this. Okay, this is another duplicate. So what we can actually do is have, similar to our query integer input, let's just have a query string input function. String input, and then this would be next line, right? So string, so we're gonna have to get our response, right? So our string response, right? So like user response equals this dot query string input, and then let's just take this, play again, yes or no. Okay, play again, yes or no. And yeah. So let's do like a colon here. Okay. This is supposed to be a string. Okay, so we have our user response, right? And basically, if the user response dot equals, if it's equal to yes, right, or it's equal to, right, just making sure if the user hits yes, so we're going to do upper and lowercase, then return true, right, so the user does want to play again. Otherwise, we return false, right? So here we have some checks if it's invalid input. What we can basically just do is if they reply with a bogus answer, we'll just cancel the game instead of just replying invalid input and like not playing the game. So there's that. But there is one thing we have to do here, which is reset our game stats, right? So here we're gonna have another function, this dot like reset current. Like reset current session stats, something like that, right? So this is just going to reset our guesses and our current count, right? Because those need to be reset from game to game. So we're going to have that private void reset current session stats. And we're going to set our current guesses count equal to 0 and our current guess equal to 0. So I know I'm going really fast. So feel free, like, you don't need to copy everything I'm doing. I'm just kind of demonstrating like how to think through refactoring code. And I'll definitely push this to the GitHub. But yeah, this is how like you would reasonably go and like refactor a giant program by breaking it into smaller chunks with very simple functions. Okay, so we have our reset current stats, and then we return true, and then we return false. So I think we're good. If we go back to the top, right? Remember all the fundamentals of clean code. It should be elegant. It should read like prose. It should be simple, right? If we read through this function, this class, right? We can read it from top to bottom, right? We play a game. So to play the game, we first query the user for our upper bound, and then we have the game running with a run session, and we display the completion stats, and then we ask if the user wants to play again, right? So like a very kind of concise to statement, right? So after every function is called, it's defined right below. So you can read the entire thing top to bottom, right? So I see a query user for upper bound input is defined down here, right? Run guest session defined down here. Display completion stats defined down there. It's almost like a depth first search kind of thing, where every function has the functions that it's dependent on right under it, right? So we go here to here to here, and then run guest session, and then display completion stats and all that. So let's remove all of this, right? I guess we should have in.close, but that's not completely necessary in our case. But yeah, let's remove this. Have our main method. So now our main itself is tiny, right? We just have our guesser as a new num guesser, and then guesser.playgame, right? So let's go ahead and run this. So if we do ls, we see we have number guesser too. So what we need to do here is have number guesser as well, and then we run our main, right? So okay, same thing. Let's just do 10 this time. So I guess 5, 3, 2, 1. Okay, it was 1. We'll play again. 9, 4. Cool, we guessed it on second try. So you can see it works just as intended, but the code itself is so much more cleaner, right? To run through, we made our variable names cleaner. We have everything in the different layers of abstraction, right? We have no like low-level stuff going on here, like print statements, right? Everything is just like super easy to understand. Like we query, we run session, display completion, ask the user want to play again. Very crisp function names, short functions. Yeah, a lot of vertical space as well. You can see not everything is all like condensed into one thing, like one giant blob like it was here. So I know that was kind of fast, but I really hope that gave some insight into how to write clean code and what that kind of looks like. So yeah, and if anyone has any questions, let me know. Otherwise, we can just hop over here. Again, here's our refactoring. So workshop's almost done. I know it's been quite a bit, but I just want to cover some other general tips for clean code. So like we mentioned, like aside from what we mentioned previously, there's some other general tips that we can use, such as avoiding duplication, simplifying complex logic, avoiding magic numbers, and being consistent. So we've seen some of these in our refactor, but let's just go over them a bit again. Right? So for duplication, again, the definition of code duplication is just there's multiple snippets throughout the program that do kind of the same thing, right? So Martin quotes here, every time you see duplication in the code, it represents a missed opportunity for abstraction. So like we did with the inputs, the querying inputs, when there are duplicates, we can just abstract that into one function and then just call that function in other places multiple times. So the bullets mentioned here, hopefully that was evident in our refactor with removing the duplication of inputs, right? We raised it to a higher level of abstraction. It became easier to understand. And again, the whole reason we have object-oriented programming is to make removing duplication simple and intuitive with classes and objects and polymorphism and inheritance and all that. So, okay. So let's go over quickly about simplifying complex logic, because I think this is kind of important here. So for writing clean logic, we can simplify complex pieces of logic by capturing smaller pieces into properly named variables. So let's look at this example here. We have a giant if statement that says, okay, if user.currentBalance is greater than 0, or user.freeRides.length is greater than 0, and driver current location minus user location is less than something, and the current ride is length is less than something. Like, there's a lot of logic going on here, right? So something better we can do is take the smaller pieces of logic and write them in variables so that it becomes easier to understand. So let's look at this example. This is the same if statement. And if you look at the if statement itself, right, it's so simple, right? If can user ride with driver, then we do something, right? So imagine this is some kind of like ride sharing application like Uber or Lyft. We check if the user can pay for the ride by checking it's their balance and their like free rides length, like some kind of coupon code. We check, is the driver close to the user, and if there is space for the user in the driver's car. So it makes it so much easier to understand the logic if things are just defined in intermediate variables. So hopefully that is clear in this example. Okay, magic numbers. So I'm sure most of you are familiar with magic numbers. They're basically raw integer or decimal numbers that are used within the code that don't have much context and hence are magically there, right? So let's take a look at this example. We have for let I equals 0, I is less than data.length over 25 I plus plus. We have a from and a to, and they're multiplied by 25. So I guess what's happening here is data is being written in batches of size 25, but I don't know why they're 25, right? Why is that there? Why is it 25, right? So if we refactor it to something like this, okay, we have a clear comment explaining why we're doing the 25, and then we just remove the 25 with a max items per dv write variable. So this is actually a code I wrote in a different program. Basically, you have to, it's a simple loop that basically writes data to a database in sizes of max items per db write, because DynamoDB, which is a type of database, like restricts batches for only that size. So again, a lot clearer with comments and constants instead of magic numbers. Okay, I do want to go over consistency a bit, because arguably the biggest thing for writing clean code, one of the biggest tips, is to be consistent with your teammates and with yourself. So this means having consistent naming conventions, having consistent logic, using common conventions within a team. Like, it's so important because it speeds up the reading time, because if a developer reads code that they're familiar with, that is consistent with their conventions, they just read it faster, right? Otherwise, they have to like look at your code and be like, what's going on? Or they're not too familiar with the paradigms that you use. So if everyone's just consistent, it makes reading time way faster. And remember, reading time is very important in the software engineering industry. So a goal to have is to have all code in a code base to make it look like it's written by the same person. And again, it makes understanding the entire code base easier and allows future members to pick on conventions easier. So that's just a note on consistency. Here's a quick example. This is the same 3-sum solution on LeetCode. But there's one thing that's inconsistent about it, and that is left and right, right? So we have first index, and then we have left and then right. So, but the thing is, they all represent indices, right? But left and right don't have the name index appended to them. So this is confusing because maybe you're thinking, oh, is left and right not an index? Is it something else? Is it the element? But you have to read through the code and realize, oh, it actually is an index. But then you're wondering why they didn't put index at the end of it. So just a thing, a small thing for naming consistency, just make sure all your variable names are consistently named. Yeah. Okay, so I know that was a lot, and that was kind of fast, but I do want to have some concluding remarks about clean code. So we did cover a lot of theoretical concepts about what it means to write clean code, but chances are you're not convinced, right? You're not convinced that these are actually good practices. And you aren't convinced because this was straight up like a lecture, right? You need to go in practice to actually understand like why each principle works the way it does and why each principle makes code cleaner, right? So the craftsmanship of software engineering can only be learned by actually doing coding more and more through projects, through internships, through classes, etc. So I encourage you next time you work on a PA or a project, don't just stop once the code works, right? So usually what people do is they get their test cases working, and then they just call it a day, right? The PA is done, move on. If you really want to know how clean code works or like work on your clean code practices, I really encourage to think, how can I change my code that I just wrote to follow the clean code principles or follow better programming paradigms? And you'll actually start to understand that a lot of these heuristics make a difference and they like make sense in the overall quality of cleaner code. So I do encourage people, like if you have extra time and you finish your PA early, do try to refactor it a little to see like can I make this code any cleaner? Can I follow some principles? And you'll start to really understand like how to write clean code, and it'll pay off a ton in the industry when it actually matters. So just to touch on that. Further resources I wanted to provide in case anyone was interested in exploring the topic of clean code and software engineering more. There are two books that I highly recommend. Clean Code, which is the book I was referring to throughout this workshop, written by Robert Martin. Another one is called Clean Architecture, which is a guide on software architecture and design. It is definitely more intermediate, more advanced than Clean Code. So I haven't read it myself, but I'm definitely going to try reading it like when I'm in the industry. And like I actually like understand the fundamentals of software architecture and design. So also written by Robert Martin, I highly recommend. So another couple of YouTube videos I want to recommend. I don't know if y'all know Clement, but Clement is a somewhat popular YouTuber in the software engineering space. I recommend his videos on clean code. He goes over some of the heuristics I mentioned. He definitely explains it better than I do, so I would highly recommend viewing his videos. As well as Uncle Bob, who's just Robert Martin. That's his nickname. Robert Martin is referred to as Uncle Bob in the software space. So he has a video series on clean code, kind of explaining his book. So highly recommend watching those videos. So yeah, that's all for this workshop. I really thank you all for coming. I really hope that you learned quite a bit about writing clean code, because I think it's so important to know how to write clean code, especially when you start in the industry, because that stuff matters, like in your performance reviews, in your promotions, in your like own fulfillment. I highly recommend learning how to write clean code. So thank you all for coming. If you have any workshop requests for Hack, go ahead and go to this link and enter what workshops you want to see next. And us at the Hack team will definitely pull through with those workshops. So yes, that is all for this workshop. And I have a works site just so I don't get sued. The code for this workshop is, I'll type it in the chat, or I'll just put it up here actually. It is squeaky clean with two E's. All right, yeah, thanks everyone for coming. Let me stop the recording.